Okay, Google. Open says me.
Acknowledge activating Project Alexandria.
Welcome to part 2 of Project Alexandria. That's right, it is a hidden, complete, automated bookshelf controlled with my Google Home device. If you want to see why we built this project, the motivation and the basic functionality of how it kind of works, please click the video down below as well as you're down there. Just click a little like and subscribe, it really helps us get off the ground. Now, this video is going to be broken down into a few different components about how we kind of built both the front panel, which makes it look like a bit of a bookshelf from a distance. We'll also talk about some of the mechanical, electrical, and software components. Times for those videos in the chapters down below, or I think over here now. YouTube's system's now changed. Now, the first bit that I want to cover in this kind of more in-depth explanation of the video is the front panel and how all the kind of the mechanical components came together. Now, to do that, we've got to go back in time. So please wait a moment while we time travel. Whoa!
To my workshop, which is pretty much my garage, a trestle table, and I'm surrounded by Dad's bikes and his smelly shoes. Now, I don't really know exactly when this is compared to when the video or the project's finished, but I wanted to show off where I started from and the kind of journey I took. So the first one is the actual mechanical part and what is the foundation of the wood. Now, I could have built it all from scratch, but that takes more time and more money and more thinking, so try and keep it as simple as possible. I got myself a little shelving unit here from my local hardware store. Pretty cheap, all things considered, $38 altogether, which is really good. Now, the reason I chose a shelving unit versus, say, a cabinet unit is one, because it is cheaper, doesn't require the hinges mounting and whatnot, and two, it actually has shelving inside, which means I can use the shelves, if I want to, as, well, shelves. Another component that you will see is this piece, which is a premium plywood. It's not really designed to be in water, but that's great because bookshelves aren't designed to be in water, so they'll be indoors most of the time. And I'm using this more or less as the door on the front, so it's going to mount and then turn as well. So, like all good engineers, I didn't actually read the instructions, and either I understand why it's $38 because the edges don't actually line up on the little 4 pieces, or maybe I just done it wrong. So I'm gonna just move all the pieces around and see if there's an issue here, because it does not look right. So it's been a bit of a long workshop session, but here we are. I've been able to mount the board onto the actual bookshelf itself with the hidden hinges. There are some screws coming here, but I'm putting another piece of wood on top as the outside covering. There's a bolt here where the special little piece goes in. Something else I realized was buying a cheap wardrobe or cheap furniture, you get what you pay for. And so I actually had to put these shelves in because it turns out that's where a lot of the structural support came in, not from the outside, which I was hoping for. So you get what you pay for, and I am very cheap, so.
And we are back to a normal sounding microphone. Anyways, this part of the video is explaining how I did the books themselves. So what I did was I went to my print shop and just printed out all these photoshopped book covers that covered 30 and 40 millimeters pieces of wood. So here's me cutting them out. Once I had the cutouts of paper, I then just stuck them onto different woods of the exact length they needed to be to fit that wood, so you couldn't see the behind of it, and just glued them on. And it took a little bit, but it was quite remedial. Had some music going, listened to a podcast. Really quite fun to do this part, but that's how I did the front facade.
And we're back. That's right, you're now talking to current Sean, also known as Sean. Now, this second part of the video, I want to talk some of the electrical components, specifically the linear actuators. And to do that, I'm going to have to pull the box out of here. Okay, now welcome to the messy electrical components section of this video. That is right, we are looking at the raw electronics behind Project Alexandria underneath my little jazz hands. So the way it all works is pretty damn simple. This is a little plastic box that I recovered from the bin because I recycle. Who likes to save the planet? It's got 2 thumbs. This guy. Anyways, the way it kind of all works is we've got a relay board that controls all the outputs. We've got the actual Wi-Fi development board here, which is pre-programmed with a signal and then communicates with Adafruit and IFTT and a step-down converter. And I'll explain why we have this set up effectively. Now, you might not be able to see it from this angle, but what we have here is a spare linear actuator that I bought 2 for this project in case the first one blew up, but I've wired in the second one just to show how it all works. Now, linear actuators themselves are 12 volt input signals, and this relay board, because it's 4, also was 12 volt input, and actually was a bit higher than that, but it can take 12 volts quite regularly. So there's a lot of components here that require 12 volts. The only one that didn't is the Wi-Fi development board. Now there's no actual voltage in signal, so I had to wire straight into 5 volts. So what I've done here is the 12 volt signal comes through and goes through a step down DC-DC converter. Now this takes a DC signal and then changes it to a lower output by turning this little variable thingy. I forgot the name of it it's called. I'll put the name of it right here in the video. Now the signal comes through 12 volts and comes out as 5 volts, which wires straight into the 5 volt and ground pin here. Now it's not really recommended. Generally speaking, you should wire and power through the Wi-Fi, the micro SD cable, but I didn't want to set up a whole bit of kit just for that. I've also had this project running for 3 months, plugged in completely, and seems to be working fine. So this kind of output works if you want to try and have effectively 1 power signal in for a 5 volt input board. Now, through here is the relay boards, and the reason I wanted to use relays is I didn't understand the current that might come through the motor. Because we've got a motor, there's back EMF and sometimes a bit of issues when you wire it straight to the same board. So I didn't want these power signals to be together. So having a relay means I could separate the 12 volt power supply here, which would go a bit fuzzy, as well as the 5 volt here, so it doesn't interrupt anything on the board itself. Now the reason I chose a 4-piece relay, because you can see 4 blocks here, is because these components, you need about 2 to control a linear actuator. Now there's a few reasons why that is. You can have it set up so it automatically recoils unless it's powered. I thought that was a bit of a waste and keep it powered all the time. But effectively what happens is if power goes through this relay and is allowed to go through this black cable and the red wire is grounded, it'll then extend out the linear actuator. However, if you do the opposite, where you power the red cable and then ground the black cable, it'll then retract the linear actuator, which means you got the best control in terms of how far you want it to go out, how far you want it to stop. There's also electronics inside the linear actuator itself, which stop you from pushing too far out or coming beyond its limit. So it has upper bounds, but this means I can control medium bounds in between. Now the reason I went with 4, not 2, is because I wanted to control a Wi-Fi LED strip, which is wired through here. And they don't sell 3 relays in boards in my local shop, so I had to buy the 4 one. But I could use this one for another thing in this project pool. Anyways, let's show you how it works. So I'm going to give a command to Google. Okay, Google, open Project Alexandria. So you can see there that okay, the Google Home has now accepted the command. It's gone into this board, and you can see Wi-Fi relay 1 switched on. So power's coming through this black cable, and the red cable is permanently grounded unless the relay is switched on. Now, as it goes, the linear actuator extends out. It takes about 20 seconds because it's quite slow. Then you see this board relay switch on. This is the Wi-Fi strip, so now this is fully extended, open, pretty much it's an open position, and the Wi-Fi strip is now switched on. Now if I close it, for example, okay Google, close my bookshelf. There we go. And so you now see the second relay switches on, which means it's reversed the power through these cables, and you can see the linear actuator is actually retracting it back. You can also notice that the Wi-Fi strip has switched off, and so the power is coming through, It's completely automated, and I've actually got this timer running to beyond that time to retract. So this will actually switch off, but this light will stay on. See, the light's still on, and this isn't stopped. This one has stopped. So I've got it so it automatically does more than it is required to close the doors, just in case those times when it might have gone too far, or there might be a slight interruption, so it can naturally close itself at full length. Anyways, that was the electronics. I'll put a schematic up, and I'll try and explain some of the messier cabling through that the schematic on there. And while I wait for this slowly to open up, I want to talk about the final component, which is the software little bit. I realize that this is quite a slow little design, but bear with me for a bit. Now, the software design is actually quite simple. Once you have the electrical and mechanical parts done, the software is arguably the best. And I did use this Gmail kind of pop-up box software from Adafruit to pretty much work in the integrations with the electrical box up here in the top right. And that shall be shown now.
The final component of this video is to explain how the software behind the mechanical and electrical components work to make that kind of opening and closing with the Google kind of Home Assistant. Now, you can work with Alexa Assistant. There's a few different ones that you can use because they all go through the IFTT method. Now, the way it works is effectively you start with 3 different softwares that kind of work together. This is the easiest way I found to do it. There might be a way to do it in 2, but I think just with the 3, it was cheap, it was easy, and very useful and very functional for what I've done. So the 3 bits of software that kind of work together are, one is IFTT, the second is Adafruit, and finally is the actual like software operating system of the Arduino IDE. So all 3 of them work together. It was the cheapest way for them to all work, and so now I'll be going through how that kind of clicks together on my computer screen. So the 3 things that you need to set up are 3 different accounts. Well, sorry, 2 accounts, and then 1 is Arduino, which you don't need to worry about. Now, the first 2 that you need to set up are IFTT, which is if then that. You need to set the account there, and then you need to set up an IO Adafruit account, which I think was the easiest way to kind of have this all click together. Now, once you have them set up, you need to connect Adafruit and IFTT together. It's very simple in IFTT. Once you have a login, you just connect that service to it, and then there's a natural communication between the 2, so that's fine. So to work with IFTT, let's pull this up. So IFTT, for those who are not aware, IFTT stands for if then that. This is just a software that's designed to help create automations around your home. So you can do things both on software, you can use different controlled apps at home. Me, I like Google, so I've used a lot of things to use with Google. The way to do the connection one is once you have a connection with Adafruit and there's a relationship there, you need to create 2 applets. Now you can see I've got a lot of applets here. I'm only going to use 2, but I've set up a few in my day. But the 2 that you really need for this project is open and close. So effectively what it does is IFTT is a trigger, then an automation system. So for me, I created this little app, and so I've got 2 parts to this applet. So the first applet, you have a trigger, so if, and so this is the Google Home, so both my Google Assistant and Google Home are connected in this way, and you set up a few different words or phrases to create and open up the bookshelf. So I've got 3 here. Open Project Alexandria is probably the one I use the most. I could use a drink because all my alcohol, my like nice alcohol is in there. Might as well. And then you can also choose what it says back to you. Sometimes you can make it say dumb things, but me, I just went very, very basic. Anyways, so that is the trigger for the applet, and then what it sends. Now once Adafruit is connected, you can just click plus, add the action after the trigger. And so for me, once you have an account set up, you connect to a certain feed, and then you send data. Now, because the way the door works, it's binary. You only need it to be either open or closed. So what I've done is I either send a 1 if I want the door to be opened, or a 0 if I want the door to be closed. So the applet, this one and the other closed door applet is the exact same. Effectively, the only change is the words, the phrases to close and open the door, and the data it sends, 1s and 0s. Now, once you have the IFTT section completed, you need to set up your dashboard, and that's what that feed open close that you saw over here was. This feed name responds to this little data set. Now, once you have a dashboard set up, and you've connected Adafruit and IFTT, as you've already talked about, you set up a little dashboard. Now, a dashboard is a way to visualize data in and out, control different devices. There's a lot of things you can do with it, but again, the door is quite simple. So all I need is an on-off switch. Now, if I click this button right here, you can kind of hear in the background and slowly see in the background here that the actual door is opening. So it's effectively, this is the main plug or switch to turn on and off, which does it remotely over Wi-Fi. There is no cables. There's no little extra tricks. Okay, so to illustrate the interaction between IFTT and Adafruit, I'll now explain it. So my hands are up in the air. I've got my Google Home on the top right corner. So, okay, Google, open Project Alexandria. Now we should see...
Activating Project Alexandria.
There we go. So it's actually switched on the button in Adafruit without any control. And now is now opening the door behind me, which is quite fun. So again, if I say, okay, Google, close my bookshelf.
Confirmed closing Project Alexandria.
Controls the button immediately without me needing to do anything. So that's exactly where the control comes in place. I realize that's quite loud in the background. I do apologize. Anyways, once it's all done, you need to click on My Key. This gives you the data to control to the relationship between Adafruit and your Arduino IDE. Now, the way I did it was I took a bit of coding and like a project designed by this gentleman named Brent Rubell for Adafruit back in 2018. Effectively, he made a 3D printed little mailbox with a little flag on a servo. So every time he got mail, it would just pop up the flag to show that he's got new mail, which is kind of cute and a good little project. I used the foundation for that for my project. I don't take credit for the software, that's all him. I've just made edits to it, so I've actually kept the initial components there for his video. For his project, sorry. Anyways, the code takes two different projects, two different files. One is the actual coding itself, and the other one is the config file. Now, what we were talking about before over here, the click My Key. Once you hit My Key, it'll give you some data sets. One is the username and IO key. You need to then update that over here. So update these two files as well. And that will give you the connection between both your Wi-Fi development boards as well as to Adafruit, which is that relationship that you just saw it opening and closing. Additionally, too, you must update your Wi-Fi name and password. It doesn't really make sense having a Wi-Fi controlled thing without Wi-Fi. So I'm pretty sure these ones only take 2.4 gigahertz. They don't take 5 gigahertz Wi-Fi routers, but most of them are given an option of both, so you should be fine. Just make sure you choose the lower gigahertz for Wi-Fi board. Some of this stuff is just the setup, don't need to worry about that. Now, the code itself is fairly self-explanatory. I've commented it and added things all the way through, including the config. Again, most of this coding is done by Brent. I've just built upon it. I've put a bit of code in, for example, if, for example, you lose power, it will try and shut the door if you unplug and replug it in. So you can just do that a few times in case the door is left open and you can't get to Wi-Fi. You can just unplug and replug. It has come handy when I was doing some initial testing, so I've left that in there. If you don't want that to be part of your software, just remove that. Just be careful in case you do get stuck in a situation that you have to manually shut the linear actuator. This stuff, again, just gives a little indication that this step is done. I didn't put any LEDs in there. I probably could have, but you're trying to hide it as much as you can. The one thing that's probably good to notice is, generally speaking, in Arduino, you have a lot of your code run in the loop. Now, because of the way this works and how it's set up, you have a big handle that does most of the coding, and the loop is just run, which is one line, which I thought was kind of interesting. The actual coding itself is mostly in this void handle. So it talks about setting a general position of the door. We assume it's closed initially, which makes sense. You're going to have it closed more often than you're going to have it open. So if, for example, Adafruit detects that a change has been made now that the door is set to high, and we assume the door is closed, it'll then open the relay and run for 20 seconds. So that's what this run time is. So it just opens the relay, turns on that relay switch, the linear activator starts to extend. After that completes, it'll then switch on the LED relay, which is why the LED switches on almost at completion, but not all the way. And then it'll turn off both. I'll turn off the linear actuator, but keep the LEDs on because that's the one time you want it on, and also print it off. So during your QA session, again, you can comment that out. We'll also change the position of the status of the closed. So closed equals 0 means closed equals false, therefore it's true. I realize that's backwards, but it doesn't really matter. Now the other part is the other if, another else if statement. So if it is already open and we've changed the status on Adafruit to low, and we assume that the door is actually open if this is false, it'll then close the relay. One thing you'll notice again, when I talked about the electrical component, was the delay. I've increased the time of the delay greater than the time for the open. The delay in the close is longer than the delay in the open. That's just to make sure it's fully shut. And there is software inside the linear actuator that makes sure that you don't go past that point. Now that is effectively all the software for the code. It's really quite simple, and I really recommend trying to do this one on your own free time.
And that is it. That is exactly how Project Alexandria works from the bottom up. Now, this is very much a little bit of a fun project because I just had the idea around linear actuators, but it was so much fun to build. Again, before you go, please like and subscribe. It really does help us out. We're just trying to get off the ground. Any of the money that goes through our Patreon doesn't go to us personally. It goes into building projects like this. So if you have an idea for a project, just allocate that with the Patreon donation, and then we'll see if we can work that into our schedules. Please, thank you very much for watching. I hope you've learned something. I'll see you in the next one.